Today we're looking at quadratic functions. A function f is a quadratic function if f of x is a equals ax squared plus bx plus c, where a, b, and c are real numbers, and a does not equal 0, so we do have an x squared term. This will be the graph of a parabola. By completing the square, any quadratic function can be written in the form a times x minus h, the quantity squared, plus k. In that case, you know that f of x equals x squared is a parabola that looks like this, where the vertex is at 0, 0. This, of course, moves the vertex left or right, and k moves it up or down. And we know also from transformations that a will make it fatter or skinnier, depending on whether it's less than 1 or greater than 1. I'm going to use completing the square to change this to vertex form. So we'll have x squared plus 2x plus, we're going to add something here to complete the square. We'll have minus f, minus 5 is still there. I left some room. And because we're not changing the left-hand side, if we're adding something, we also have to subtract the same thing from both sides. We're just going to group these two things together. Now we've got a 1x squared, so this will be x plus, because this is plus, half of 2 is 1, and that's squared. There we are completing the square. Remember that 1 squared is 1. We're adding it, and we also subtract it. So combining these two terms, we get minus 6. So f of x equals x squared plus x plus 1, the quantity squared, minus 6. And the vertex of this parabola is at negative 1, comma, negative 6. Because the plus 1 moves it 1 to the left, and the minus 1 moves it down. Now, when we get a case here of having a number where a is not 1, we're going to factor that negative 3 out of the first two terms. We'll factor it out. What do you take times negative 3 to get negative 12x? That will be plus 4x. And we'll complete the square inside that. The negative minus 13 stays. And this is subtracting. It's negative 3 times this. So we're going to make it positive 3 times the same thing. This being a negative, this being a positive, they'll cancel each other out. Completing the square, x plus half of 4 is 2, the quantity squared. 2 squared is 4. Notice that's in the parentheses times a negative 3. So we put in the parentheses over here times a positive 3, and they cancel each other out. And then we'll have negative 13 and positive 12, so minus 1. So this parabola will have a vertex at negative 2, negative 1. Now let's try this one more time, and we have a negative 1/2 times an a squared. So f of x equals, let's take the negative 1/2 out of the first two terms, x squared. Now what do I take times negative 1/2 to get a positive 2? It will be a negative. Negative times a negative will be a positive. And 2 must be half of something. It's half of 4. X plus, here's where I'm completing my square. I keep this plus 2 on, and then this is a subtract, so I'm going to make it add a 1/2 times the same thing I add in here. So it's a negative and a positive. They will cancel each other out. Negative 1/2 x minus half of 4 is 2 squared. and 2 squared is 4, adding 4 to both sides. 1/2 times 4 is 2 plus 2. This will be plus 4. And my vertex is at 2, 4. That would be the vertex of this parabola. Looking at parabolas, the very simplest parabola, if f of x equals x squared, 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, we would have 3, 9 and negative 3, 9. The domain is all real numbers. The range is from 0 to infinity. And 0 is inclusive since that point, 0, 0, is on the parabola. Parabolas are symmetric. We could fold along this dotted line and they would match up. So they're symmetric with respect to a line, and this line is called the axis of the parabola. The point where x intersects the parabola is the vertex, either the lowest point or the highest point. If g to x equals a times x squared is a parabola with a vertex at the origin that opens up if a is positive, down if a is negative. The width of the graph is determined by the magnitude of a. It is narrower if a is narrower than the basic f of x equals x squared. If the absolute value of a is greater than 1, it is broader, fatter. If the absolute value of a is less than 1. By completing a square, any quadratic function can be written in the f of x equals a times x minus h, the quantity squared, plus k. The graph is the same as the graph of g of x equals a times x squared, translated h units horizontally. To the right, if h is positive, notice it's minus h. To the left, if h is negative, and k units vertically, up if it's positive, down if it's negative. What I do whenever I'm getting ready to graph is to number my graph. My basic one, I've got negative 2, so that means it's going to open down, and the 2 means it's taller, skinnier than my basic x squared. So 0, 0 is still a point. And I would have a point 1, 1. But because of the negative 2, I take that 1, 1 times negative 2, it becomes 1, negative 2. And this is symmetric, so if it's here, it's mirrored over here because of the symmetric. Now for 2 squared would be 4 times negative 2, I'm going to have negative 8. 2, 4, 6, negative 8 will be here, and it's mirrored on the other side. So my parabola becomes basically this shape. Notice I have definite points I use for my parabola to make it. How does it compare? Well, it opens down, and for here it opens down and is skinnier. For y equals 2x squared, the thing is it's just flipped across the x-axis.